everyone hear me? Thank you so much for inviting me to Brazil. This is my first time here, and I'm excited about it. I didn't expect so much rain today, but I think neither did you. What I'm going to talk today about is about knowledge in open innovation contexts. So in one sense, I'm going to be quite abstract and try to connect with some general ideas of knowledge. On the other hand, I'd like to be a little bit more specific, because I would like to talk about the managerial implications of working with open innovation. But I'll try to do that by talking about the general problem of knowledge integration and an internationalization of the economy, which I think you're all aware of. And then a little bit about open innovation and the knowledge prerequisites. But the main thing that I would like to talk about is various types of knowledge, or various contexts where we find knowledge, and how that could be managed by drawing upon a number of different illustrations. And then I try to make some conclusions for the management of knowledge in open innovation. So I'm the head of something called the KITE Research Group, which is located in Sweden. We're about 15 of us working on the general problem of knowledge integration and an internationalization of the economy. And I would say that in developing this research, what we did was to identify 3 common trends, which we think are very, very important to understand what's happening in the economy today. Of course, one is globalization, with the rising force of emerging economies like Brazil, of course. The relocation not only of production, but also of R&D, science, knowledge, which goes through in the development of science and technology. Not only is science and technology developing at an increasing pace, it's also becoming more complex, distributed all over the world. It's not the case that we will find all science, knowledge in the developed countries. We'll find them more and more all over the world. And finally, we see that markets are changing. Not only are emerging markets becoming more important, also mature markets and emerging markets are affected by deregulation, re-regulation, changing business landscape. All this paves the way for the problem of knowledge integration. And we are doing research on project organization, which you will hear a lot about today, and knowledge integration as a means, as something you can use to integrate knowledge. Outsourcing, integrated solutions, and strategic partnering. Strategic partnering, when we wrote these proposals about 5-7 years ago, open innovation wasn't as hot as it is today, maybe. So we called it strategic partnering. We probably would call it open innovation today. So what we've done, we worked in 5-6 years in this research project now. We have just came out of the book last year where we compiled some of the research. This is our group, somewhere in Sweden in the summer. I can't tell you, and I can tell you, it's not the case that it looks like this now. It's pitch dark in Sweden. So it's really nice to go to Brazil. So we've listened all day to various presentations of open innovation. For me, there is one very important implication of open innovation, and that it is that it's increasing the degree of specialization of knowledge. So we see that we need individuals, organizations, projects that are increasingly specialized in utilizing knowledge all over the world. With the increasing specialization, that creates a problem for us, because we need to find mechanisms and processes to integrate that specialized knowledge. So what I would like to talk about today is some features of knowledge and how we can think about the integration of that knowledge. I'll do that by spending about 10 minutes talking about 3 different dimensions of knowledge that I find particularly important for analyzing knowledge, and then try to outline a cube. And we'll see how it goes. on various contexts of knowledge where you can think about how to manage knowledge in different open innovation contexts. So here we go. The first question we can ask when it comes to knowledge is, who knows? If I would ask each and every one of you, you'd probably say, I know. I know when the nation of Brazil was founded. I know how to ride a bike. I know how to manage my group. I know something. That's usually how we think about knowledge. In the way that we as individuals, we know something. Of course, this has tremendous implications for management of knowledge. If we believe that most knowledge is captured in the individuals, then we have to manage individuals, right? But if you start thinking and ponder a little bit further than that, you rapidly see, no, it's not only individual knowledge in this sense. So you think about the Brazilian football team, arguably the best football team in the world. It's not only a group of individuals. When the Brazilian football team is playing well, they're playing well as a team. There's something they know collectively, how to play the game. Also, when we're working in groups, teams, in organizations, we do actually know something together. We need to develop some kind of collective knowledge, which is not only a property of each and everyone, but actually more than that. It's something that we know collectively. You can go back to your own education system and ask yourself, what did I learn in school today? Was it the case that it was my knowledge? No, I learned something about mathematics or physics or history or language or something. Something that seems to be a collective property of our society, something we develop together. So if we're going to talk about the management of knowledge in this sense, we need to talk also about the collective properties of knowledge. The second question you can ask is, what do we know? First trivia today. Who is this guy? It was close. Who did Plato, he said. Who did Plato write about? Aristotle was the successor of this guy. Socrates. What did Socrates do? Who was he? What kind of man? He was walking the streets of Athens like a bum, questioning people, arguing with them, right? Trying to develop their minds, get them to think. Why did he do this? We still call it the Socratic method, right? You argue with people, you get them to develop their arguments, because we have a belief that if you can explicate your knowledge, that kind of knowledge is more valuable because we can start codifying that knowledge, articulating it, debating it, and we have progress in knowledge. This is science. Socrates, in a sense, was the first scientist in that sense, or at least as we know him. And it's quite interesting, I think, that the Plato's books, they're not called books. They're called dialogues, because it's the dialogue. So we have a society, the modern society, which is very much built upon explicit knowledge. However, it's questionable whether explicit knowledge will help us always. In many situations, we're not using that explicit knowledge. So I put Roger Federer here and a kid riding a bike, not using this explicit knowledge. In the sense that when they're actually executing this specific task, they're letting the knowledge becoming a part of themselves. How many of you have a driving license? Oh, quite a few, right? You remember when you took your driving license? Ooh, it's quite difficult, right? The clutch, the shift gear, everything. My mom and dad being very angry with me. I was very angry with them. sort of fighting. And I had to spend a lot of time understanding how to drive the car. And this was even before getting out in traffic. Because the automaticity that you develop when learning how to drive the car has a lot of implications. Because if you know how to drive the car, you're not a danger or a hazard in traffic. You can actually watch traffic once you know how to drive the car. The same goes with bikes, skiing, football, whatever exercise, cooking, or actually being a good manager. You routinize, you utilize what Michael Polanyi called the tacit knowledge, the tacit dimension. To tell you a personal story, I'm just building a summer house. So I try to help the carpenter once in a while. I go there, I take the hammer, and I hit my finger. Why do I hit my finger and not the carpenters? Well, Michael Polanyi said, because they're dwelling the hammer in. And what he meant was that they're making the hammer an extension of themselves. So instead of me thinking about the hammer, every time I hit the nail, they don't have to. They can talk and hit the hammer because the hammer is like their arm. If you look at a very good software programmer, it's the same thing. They sit there, drink Coke, they do a lot of other things, but they've learned the skill. Also learning a language, same kind of process. Tacit knowledge is extremely important to us. The third aspect or third dimension I'd like to use in this developing this cube is, let's see if this works now. No, it didn't. Nope. You think you can point to this one? Yep. As a hobby, I do some economic history. Actually, my dissertation was partially about economic history. I wrote about the electrical industry. And there were two main figures to me in the history of electricity, especially in the US. I think the first one up here you're quite familiar with. He was mentioned this morning. Thomas Alva Edison, the Wizard of Menlo Park. What he was very good at was exploring new ideas. He came out with the incandescent lighting. He came up with the first, as we heard this morning, the first electrical system in New York, which was a low voltage direct current system. Very good in small areas for lighting. At the same time, in the US, hydropower was founded. And they were going to build Niagara Falls. And they're going to use Niagara Falls to power industrialization of Buffalo. They couldn't use Edison's system. However, there were a lot of other innovations going on at the same time at the end of the 19th century. This man, George Westinghouse, were able to compile all that knowledge, especially regarding transformers, understanding what you need to do is to use an alternating current system using a transformer to elevate or increase the voltages, to decrease the losses, and then transform it down again to Buffalo where it could be utilized. George Westinghouse didn't invent much. In a sense, he was doing open innovation 100 years ago, or more than that, 120 years ago, by incorporating those technologies, exploiting them, and utilizing them in building this new system, which has been so important for us today. So now we have 3 dimensions, and those 3 dimensions I'm going to use to develop this idea of a cube. So I'm going to talk about 8 different knowledge contexts here. So I'm going to go through them one by one and give some examples where I think, in a sense, I'm being very analytical here in the sense that I'm taking things apart that really should be maybe put together. But let's see where we leave. So if you start in thinking about combining these dimensions, what could we see if we have individual, explicit knowledge that is aiming for exploration of new ideas? arguably what we find is the scientist. The idea of the pure scientist. And in a knowledge economy, what is more important than the scientists that are going to bring the new ideas into fruition and that we can use in our open innovation system? The dynamics of the scientist here exemplified by Marie Curie, who's quite unique. She's the only Nobel laureate who's got actually the prize in 2 different categories, and she's one of the few women ever to earn it, and she earned it very many years ago. It's the idea of the scientific method. You develop hypotheses and you test these. How can we integrate knowledge in such a fashion? One idea which was developed by the Austrian economist Friedrich von Hayek in the 1940s was that this is actually what we do in the markets. What we do in markets is that we have all these individuals or companies with different types of knowledge that can transact using the price as a coordinating mechanism. In the modern terms, we can think of crowdsourcing. You put up a price, and you give a lot of individuals the opportunity to provide ideas that you can use, and you pay them a price. So you're using the market mechanism to integrate different types of individual knowledge. If we go to the next one, if we take individual knowledge, explicit knowledge, which is used primarily for exploitation, we can think about Cicero arguing in the parliament. We can think about being a professor myself. I can go back to myself. This is what I do. I go here. I'm the rhetoric, the orator. I try to develop arguments. How do I do that? Well, I do that primarily by reiterating, replicating, and recombining things that we already know. Of course, this is not what we do in consulting, for instance. We're not reinventing the wheel all the time. What we try to do is to take fundamental ideas that we know about and provide them to customers so that we can integrate different pieces and create new business models, new ideas. But primarily, we do this, we try to avoid creating new things all the time. In the third context, if you think about what could it be being an individual, having tacit knowledge primarily utilized for exploitation. Maybe it's the mouse here, sorry. No, not really. What I'm thinking about here is really the craftsman. If you think about the development of crafts or agriculture, or maybe a lot of actually modern professions too, how we develop knowledge is very much by developing the kind of skills that I talked about when we were driving the car, riding the bike. We go by trial and error. You remember the first time you tried to use a bicycle? You bike in one direction, you fall over, it hurts a lot, you try a bit more, you fall over the other end. It's a big trial and error process. You don't have a theory for it. You have to go piecemeal all the time. What you do, this is also going back then to Michael Polanyi's philosophy or other philosophies, is the knowledge integration that the individual do here is particularly using integration from various particulars, trying different isolated actions and integrating them into a whole. So for instance, my example with the hammer, letting something, in this case with my bike example, becoming like an extension of myself. And we can think about using the computer. I'm terrible, for instance, in typewriting, and I'm really impressed by people that are good in typewriting. Further, we could move along and think about, if you're an individual, using your tacit knowledge to explore new things, what could that be? Well, I think we could recognize these individuals. They've also been talked about today. Maybe to me, one of the prime examples is actually Thomas Alva Edison again, who never really went to school. Another guy, which we heard about this morning, who never went to school, is Steve Jobs. Another guy without much scientific training is Leonardo da Vinci. What they did was to develop ideas through engineering. The idea that you actually, rather than starting in theory and to do something and then test it, you start in the end. What is it that I want to achieve? And then you try to achieve that by experimentation using variation of parameters. In one sense, Leonardo wasn't that a good engineer. Recent attempts to rebuild all his different weaponry and flight, aerials and all that didn't work that well. But that's probably because maybe he didn't develop that skill that much. Steve Jobs, as we heard, has been experimenting. Of course, he's built a company, but to many people, especially if you read the biography, he seemed very individualistic still, although he had an entire company. So the integration mechanism is developing some kind of connoisseurship. You know, connoisseurship, when you're good at wine tasting, you're good at eating meals, you know how things could, getting the feel for things. And you do this by experimentation, of course, and by developing different types of artifacts rather than theories. You develop things rather than having a grand theory. Moving on to what could it be to be in a collective, developing explicit knowledge and explore new things. This is science, big science. We develop objective knowledge in science through the collective, rational, critical examination of things. So here we have him again, Socrates. What's this? We have a lot of engineers here, right? Electricity. Fusion. Ohm's law. Ohm's law. I think we learned it in school, all of us. We can't really see here, but here you have Maxwell equations. How are these distributed? In scientific papers, in books that were distributed all over the world. To give you a very recent example, we have here what was going on in CERN in Switzerland, where they tried to find the Higgs particle, the boson. Here we have all the people here being very happy when they found it. And the news spread immediately over the web, right? In the scientific community, the news went out. So the knowledge integration mechanism here that we are using is very much codification. Development of codified laws like Ohm's law or Maxwell equations that's open to criticism, that we can diffuse all over the world and people can start arguing about. One example relating to open innovation, which I find interesting, is the open source. If you go into an open source community, what do? They develop code and then they argue about it, whether it's the right way of doing it or not, right? So it's a bit like science. And they have something to talk about. It's not only the tacit experience, you have the code that you can discuss. Finally, or not finally, sorry. If you have something that's collective, explicit, and goes for exploitation, we can talk about rules and instructions. How many of you think that you work in a bureaucracy? A bureaucracy is an organization that's developed. It has a lot of knowledge, but all the knowledge is written down in codes and instructions how people should behave. So the knowledge, instead of having people going around knowing what the organization knows, we have them in rules, in instructions, telling you what to do. So what you have to do to manage knowledge in this kind of organization is you have to develop standardization, and it's almost like a logic. You develop like, if I do this, then I should do this, which can then be replicated and scaled up tremendously. I don't know if you see it, but I put Charlie Chaplin here. Do you remember the movie Modern Times? Where he made a joke of this. It wasn't that nice a joke, in a sense. But, of course, we had bureaucracy. But I also think in modern times, when we think about open innovation, one of the strongest, I think, theories for open innovation is actually modularity theory. And the idea that you can modularize components. And one of the best books that we can use, I think, in thinking about this, is Design Rules. And we develop specific routines. We know how to do certain things. The problem, of course, with that is that we know that that might easily be stifling innovation. If we do things the same way we've always done it because we want to do it according to the rules of the profession, we're not going to innovate much. We're going to be as incremental as the bureaucracy. So it's a very strong mechanism, but it builds upon socialization, that we're actually sharing knowledge with each other. Finally, thinking about what could be collective knowledge that's tacit, but aiming for exploration. Here, I would like to come back to the idea of the project. And this is an idea I haven't developed on my own. I owe a lot to Professor Lars Lindqvist, who's working in our group and was my former supervisor, who's written extensively about this. But the idea here is, in complex problem-solving situations, it's not sufficient with the feedback that we use when we learn how to ride the bike. When riding a bike, we don't need to develop a theory about riding the bike. It's a sufficiently simple situation. In many situations you're facing, in difficult engineering tasks, I put a couple of examples here. I think some of you would know what this is. It's on the border of Brazil. It's called Itaipu, I think. I probably pronounced it wrong. Itaipu was for a long time the largest ever dam project, power transmission project using high voltage direct current. So I'm coming back to Edison. Of course, what happened in the history of electricity was that direct current was rediscovered. Because if you want to transmit energy over long distances, or you want to be able to switch back and forth, like between two countries, it's very useful to use direct current again. This was one of the major projects in the 1980s. It's a very complex problem. It took a long time. You had to have a lot of different type of skills. You had to work both within companies, outside companies. You created consortiums of companies doing this together, even competitors. Probably the very beginning of the idea of complex projects is coming from the Apollo project, putting a man on the moon. And we also heard about that recently. The knowledge, these kind of knowledge, and of course the Rio, you're having the Olympics here. So, and that's quite a complex project in itself. So it's not sufficient only with feedback. What you also need is feed forward. You need some kind of mechanism to develop a theory. And one could argue that in projects with highly differentiated people, the difference with community being that actually you have people that are different. So they're all not surgeons. They're all not mechanical engineers. They're actually people from marketing, from different organizations, from engineering, from finance, from public relations, whatever, that need to work together. And in order to be able to connect to each other, because that's the way how to develop a project, is that you need to connect. You need to be aware of the goal where you're aiming, and you need to start articulating that tacit knowledge that you go around with. So in our research, what we try to do then, to give you a few examples before wrapping up, is to look at how do firms do this within themselves, but also in collaboration with others. So a typical project would be this. ABB is a Swiss-Swedish company that produces motors for railways, among other things. One problem in developing these motors is that you have roller bearings, you know, the bearings that actually, the balls in the bearings are made out of steel. Steel is conductive, just like the rest of the bearing. And you're having an electrical motor. So the entire motor is conductive all the way down to the rail. That creates problems. ABB wanted to solve that problem. So they started, why can't we use composite materials instead? We know nothing about composite materials. We don't know much about bearings, really, because we're buying all the bearings from the suppliers. So they start collaborating with SKF, which is one of the 3 major manufacturers of bearings, in this project. And as Professor van Haverbeck said previously today, there were some IP issues. How are you going to solve these? In this case, they gave the patents away to SKF to implement them, and also to other companies. But what we're trying to do here is how do you actually work together here? Well, we argue you have to work a lot with these kind of articulation because you're coming from different situations and you need to explicate what you know. Otherwise, your project won't be running. Similarly, we have people from Scania here today. They needed to develop a new fuel injection system to comply to new environmental regulations. They started to cooperate with Cummins. So you have Scania outside Stockholm in Sweden cooperating with Cummins in Columbus, Indiana, which is a really small place. Also working for a long time together to develop these kind of ideas. Again, the engineers, there were engineers of different types. It had to be marketed. People have to start to articulate that knowledge. To give you a final example, one of my PhD students studied product development at what's now called Toyota Material Handling Europe. The development of a forklift warehouse truck. What she found was that in these situations, you have all these individuals trying to work together, some of them within the organization, some of them outside the organization. Actually, most of the work, most of the knowledge is developed by these specialized individuals in their departments, sitting at their desk or working alone or in other groups. But in the projects, they have to oscillate. You have to find a way to oscillate between working on your own, coming back to a project, because what you do in the project meeting is to articulate that specific knowledge that you learned in your specialized field in order to be able to integrate and solve complex problems. So the management here becomes an oscillation between various types of knowledge as the project develops. So what did I want to say here? I think there are 2 conclusions from this exercise of trying to analyze various types of context. The first one you have to ask yourself is, okay, I'm saying here, I'm going to work with open innovation. That implies that knowledge is more and more specialized. But what kind of knowledge is specialized? What is the type of knowledge that we're utilizing in our company, in our organization? And how can we understand how to integrate that knowledge? The other problem, which is even worse in a sense, is how to organize for the integration between different types of knowledge. And here's where you arguably can say, as we've heard previously today, that the idea of working more in project-based organizations allow for both knowledge integration in the project, through the project in terms of developing project-based firms which are primarily executed by projects. And finally, in having these kind of organizations, you need to have knowledge integration also between the projects, because every project is to some extent unique and developed for specific, solving a specific task. So one of the major challenges is how to find mechanisms to support knowledge transfer and learning between projects. And if this framework could be used in some way to develop those kind of capabilities, I would be very happy. Thank you very much.
Bem, a gente vai agora para o intervalo. Eu vou pedir a gentileza para vocês, para a gente fazer um intervalo um pouco mais